All right, you guys, let's go ahead and go over this. So question 1 says, Matt is in the Glee Club and the band. Where would he be? B. Yeah, this is Glee Club and band right there would be that region. Okay. Sue is not a senior and is in the Glee Club. D. Yes, that's right. Charlie is a senior who is in the Glee Club but not in the bands. Where would Charlie be? A. Yes, that's correct. And senior in the Glee Club but not the bands. So notice that the word but can sometimes be used to mean the same thing as and. We could read this as Charlie is a senior who is in the Glee Club and not in the band. That's another way that we could say it. And that one kind of shows up on the homework a little bit. Donna is not a senior and is in the band. Is that E? Okay, any questions on the first ones here? All right. True or false? All students in both band and Glee Club are seniors. What do we say? True? All seniors are either in the band or in the Glee Club. False. All students not in the band are seniors. False. Okay, questions on any of these? Would you like to have any of them explained? Feeling good on these? Making sense? All right. Let's take a look at some algebra here. So for number 1, what should I do first? Combine like terms. Okay, so we have a -5 and a -6. What does that become? Yeah, so I have 4x minus 11 equals 1 plus x. Now what? X minus x, that's 3x minus 11 equals 1. Then add 11 to both sides, 3x equals 12. Last step, divide by 3. Okay. Right here, when we're subtracting x from both sides, what property are we using? What property is that? Subtracting x from both sides. Turn to your partner. What property is that? All right, what do we think it is? What property has to subtract the same thing from both sides? Rachel?
Is it the subtraction?
It is the subtraction property. Yeah. This is the subtraction property. Okay, so it's not a trick, right? Might have seemed like I was asking a trick question, but when we subtract the same thing from both sides, that's the subtraction property. So here, when I add the same thing to both sides, what is that? Yeah, addition property. When I divide both sides by the same thing, what's that? Division property. Yeah, okay. So these properties are not supposed to be complicated. They're not supposed to be tricky. Some of them might be a little hard to remember, like reflexive or symmetric, right? It's hard to maybe get those confused, but the other ones should be pretty easy. Okay, we're going to use another property right away. Number 2, what is it? That's our first step.
Distributive.
Yeah, distributive. We're going to use the distributive property. and distribute that -7. When I do that, am I adding or multiplying or something else? Multiplying. So this would be -49 plus 35x minus x. What does this become over on the right side there? 34x. All right. I'm gonna use the addition property here. How many x's do I have now? 39. Still have this. Still have this. What should I do now? Add 49%. All right. And then last step here. Stop at 39. I would guess that that's 2. Is that right? Okay, so my real result was 2 equals x, yet I wrote x equals 2. What property did I use? Symmetric, yes. I used the symmetric property to switch that around. Because x equals 2 sounds better than 2 equals x. Okay, so we're gonna keep reviewing algebra throughout the year. So if this is really easy for you, good. Even LeBron James practices layups. I promise. If it's not that easy for you, good. That's why we're practicing it. Okay? So even if you're thinking like, oh, this is boring, I know all this, I know all this. Well, you know, I'm still practicing it and I'm way better than you at it, so there you go. All right, we're gonna take some notes. We're gonna learn some logic laws. Let's see how the page works. Should get some measures. Yeah, I'll get them in a second. So we're gonna learn some laws of logic and also some errors. So these actually come into play a lot in real life when someone's trying to make a logical argument. You could think about like a politician trying to make a case, or like a lawyer trying to make a case, or even if you're just arguing with your friends about something. It's important to have good logic when you do that. Taylor, you go ahead and close the computer, please. So we're going to learn 3 laws and 2 errors. Let's zoom in a little bit. The first one is called the law of detachment. So the law of detachment looks like this. It says, if P is true, then Q is true. P is true, therefore Q is true. And symbols, don't worry if that seems confusing. We're going to go through some real examples. So in symbols, it looks like this. If P, then Q, P, and we get these little 3 dots right here. These 3 dots mean therefore. This would be our conclusion. I'm going to say Q. Yes. Yes. This is a valid logical argument. Here's an example of one. If I play, then I win. I play, Therefore, I win. I don't love this example because this statement, this first one here, is not something that's objectively true. But here's an example of what it would look like in words. Another example of this could be if it's Wednesday, then the day before was Tuesday. Today is Wednesday. What could we conclude from that? Yesterday was Tuesday. Next one is called the law of contrapositive. So, law of contrapositive starts off, we'll look at the symbols first. If P, then Q. What would the contrapositive of this statement be? Turn to your neighbor. What would the contrapositive of if P, then Q look like? Okay, what would the contrapositive start with? What would be the first letter? Not Q. And then it would go to not P. Okay, so the law of contrapositive is going to follow a very similar order. So it's going to go not Q, therefore not P. Notice that the law of detachment goes in the same order. So P to Q, P, therefore Q. This one says P to Q, and it goes in the order of the contrapositive. Not Q to not Q. This one is also a valid argument. And here's an example. If I play, then I win. Notice it's the same conditional statement. I don't win, therefore I don't play. Exactly. Similar logic, what we were saying before, it's like if Wednesday comes after Tuesday, yesterday was not Tuesday, therefore, what could we say? Today is not Wednesday. Okay, this one is called the law of, this is a crazy word here, syllogism. In symbols, this one is a little bit different. We have if P, then Q. We have if Q, then R. And we say therefore P, then R.
They don't label like X intercepts and stuff anymore. Yeah.
Like on the graph there?
Yeah. Like, I mean, like some people are like labeling like X intercepts and stuff.
Yeah, they don't need to label. But that's This one is valid. Okay. And for our example here, actually cross off that one right there. That one does not belong. So this one says, if I play, then I win. If I win, then I am happy. Therefore, you want to know what our conclusion would be? Yes. Therefore, if I play, then I am happy. So, an example here that I like, we could keep going with days of the week, but another example that I like to use are like from science class. So a human is a type of mammal, right? Mammal's warm-blooded creature, does not lay eggs except for a couple of exceptions. Mammals are a type of what? What's animal? Yeah, so it's the bigger category. So I could say, if I'm a human, then I'm a mammal. If I'm a mammal, then I'm an animal. Therefore, if I'm a human, then what would I say? I'm an animal, right? Law of detachment would say, okay, if I'm a human, then I'm a mammal. Bob is a human, so what do we know about Bob? He's also a mammal. Yes. This one would say, all humans are mammals. Bob is not a mammal. What do we know about Bob? He's also he's not a human. Right? He's not a mammal, he can't be human. Okay. This one here is called converse error. It starts off with if P then Q. What would the converse of this statement be? Turn to your partner. What would the converse of this be? So converse would be, what would go first? Q and then P, right? So converse error is going to go in that same order. We're going to say Q, and we're going to say therefore P. And this is not a valid argument. So notice the word error means we've made a mistake. This is not a valid argument. So this example here, if I play, then I win. I win, therefore, what would our conclusion be? Okay, our example from science class would be all humans are mammals. Bob is a mammal. Do we know for a fact that Bob would have to be a human because of that? No, because there's lots of other mammals, right? Cows, dogs, elephants. So that's why if you said, you know, all humans are mammals. Bob is a mammal. Therefore, Bob is a human. We would say that this is not a correct argument. Like if you make this argument, you're wrong. Your argument doesn't make any sense. It's an error. Because there's lots of other types of mammals. The other one is inverse error. So what is the inverse of if P then Q? What would it start with? Yeah, start with not P. So the inverse would be not P and then yeah. So this is the inverse, not P then not Q. So inverse error looks very similar. It says not P, therefore not Q. What do you guys think? Valid or not valid? Not valid. Yeah, so there's a reason we're calling them an error. So all the laws are valid. That's why they're laws. All the errors are not valid. That's why they're errors. So our example here is if I play, then I win. I don't play, therefore I don't win. I don't really like those examples. They're kind of silly. But let's go back to this example right here real quick. So if I know that all humans are mammals and I say Bob is not human, therefore Bob is not a mammal. Is this a good argument? No, this is not good, right? Because Bob, what could Bob be? Another mammal, right? He could be a dog, a cat, an elephant, a platypus. Right. So this is not a good argument. This is why this is an error. I promise you guys, if you watch the news, you will find lots of converse error and inverse error. Lots of people trying to make false conclusions out there. So the more you know about logical arguments, the better. Okay. So the key at first, again, this might all seem like, oh, how am I going to remember that? There's a lot of symbols. Don't worry, the more we practice, the easier they'll be to recognize. So here's how we would go about doing this right here. If we see an argument, I look at this statement right here and I say, okay, if I have $80, then I will buy that dress. So I'm going to represent that with if P, then Q in symbols. So now I see the next line is I don't have $80. So if I have $80 as P, then I will buy that dress as Q. Hi. Yes, you come on in. Or just you.
Yes.
Okay, so we have our statement, if I have $80, then I will buy that dress. The next statement says, I don't have $80. So what is that in symbols, Rachel? Yeah, that would be not, which one? Not P. Yeah. Okay, therefore, what does therefore look like again? Yeah, the little dots. You guys ever seen the movie The Predator? Yeah? Who said yeah? Wow. That movie's rated R. It's freaking sick though. When you guys are 17, you should watch The Predator. It's a dope movie. Therefore, I won't buy that dress. What is that in symbols? That is not Q. So I will buy that dress is Q. I won't buy that dress. So now we go back to the other page and we match these symbols to one of those. Turn your partner, what do those symbols match? All right, so what does that one match in symbols? Inverse error, yes. So inverse error, is that valid or invalid? Or not valid? That is not valid. Okay. So do you guys see that process? We're going to translate to symbols and then identify it. So let's do one more together. So if I go to Best Buy, then I will buy a VCR. The first one, always make it P and Q. Always. So if P, then Q. I didn't buy a VCR. What is that? That is not Q. Therefore, I did not go to Best Buy. Not P. Okay, so now we go back to the notes. If you recognize the order too, you might know if it's converse, inverse, or contrapositive. Converse? Sure. What is this one, you guys? Yeah, this is the law of contrapositive. Is this valid or not valid? This is valid. Okay, every law is valid. Every error is not valid. Okay, you guys with your partner, do the rest of these, follow that same process, and we'll go over it a little bit.
Where is
Yeah, once you guys finish that page, you can go to the next page.
I know it's the law. Yeah, because it's just easy.
Okay. Yeah. Yeah, it does. Yeah. Okay, everyone do the one on the back as well? Yeah.
What should I do with these? No, no. Clip it or whatever.
Yeah.
What about this one?
Just click it on. Yeah, can we put the first page from that just
Right on top.
Jackson, I think you stick that there. It's a circle brush.
Well, sit down.
That was just like so good. Me too. I know it's so fun. Now that I get this, I didn't see anything. It was interesting that I didn't What?
Nice class.
Wait, what?
Next class.
He is?
Should.
Yeah.
All right, you guys, let's check these together. All right, Jackson, will you go back to your seat, please? Thank you.
He's literally also my,
All right. So let's go through these here.
Oh, I love my control.
Yeah. If I ride the bus, then I will get home at 2:30. I got home at 2:30. What symbol is that? Q. Therefore, I rode the bus. Q. What is this? One of the errors. This is converse error. So if it's converse error, is it valid or invalid? Not valid. Yeah, sorry, it says not valid, not invalid. All right. If a pig can fly, then it has wings. If a pig has wings, what is that? Q. Then it is strange. Where did that come from? That's R. That's a new thing, right? So notice if I have two if-then statements, that's when we use the arrow for if-then. P to Q, Q to R. Therefore, if a pig can fly, then it is strange. What is that in symbols? P to R. Okay. There's only one thing that has three conditional statements. Which one is that? The law of syllogism. That's a very strange Greek word. Don't use it very much. Valid or not valid? Valid. Okay. If it's raining today, then the sidewalk gets wet. It is raining today, therefore the sidewalk gets wet. What is that one? Law of detachment. Yeah, the law of detachment is the one that seems a little bit repetitive. See how it says, if it is raining today, then the sidewalk gets wet. It is raining today, therefore the sidewalk gets wet. So it's the same thing twice. Valid or invalid? Valid. All laws are valid. Oh, all laws are valid. The law of detachment is a law. Therefore, it is valid. What did you guys just use? The law of detachment. That was the law of detachment. It was like geometry inception. If you like McDonald's, then you don't like Burger King. So should I start that off with P, then not Q, because it says you don't like Burger King? No. What should I start it with? P, then Q, always. Jane doesn't like McDonald's. What is that? Not P. Therefore, she likes Burger King. That's not Q. What is this one? Inverse error. Okay, so automatically not valid. Okay, if it is morning, then I will eat cereal. I am eating cereal. It's Q. Therefore, it is morning. What is this one? Not valid. Why? What is this?
Converse.
All right. This one here, I see if, then, therefore, if, then. So what do I probably think this is? Law of syllogism, yeah. We should check and make sure. Cold, nose will run, nose runs, tissues. There's cold again, so that's P. Tissues, yeah, this is lost. It's valid. If a person takes geometry, then they will study triangles. True. Mark is taking geometry, therefore he will study triangles. What's this one? Valid. Why? What's on it? Law of detachment, yeah. All right, you guys. So next class, I'll just look at the schedule here. So Friday's class, we are going to have a quiz, which is a formative assessment. Those are the same thing. It's going to be on 2-1, 2-2, and 2-3. So conditional statements, Venn diagrams, properties, and laws of logic. Then next Tuesday, we will have a review day. We'll go over the quiz. And then next Thursday, any ideas what we have? Test. So this unit is very short. So that's our next 3 classes. Quiz, so that'll be good practice for the test. Review, then the test. So right now, some of you guys have some missing homeworks. I know I assigned the most recent math space a little bit late. I didn't do it until partway through the day yesterday, so you might not have seen it. I'm also going to assign tonight's homework, so you guys have time to knock out those homeworks and ask me questions. I'm going to assign the math space homework right now for today. Okay.